Hello again, everyone. Back with another problem here. Continuing on vectors. So this one is problem 6 here. Which of these vector identities is incorrect? So either have to know these vector identities from your memory, from memorizing off flashcards or whatever, or you need to know exactly where to reference in the reference manual for the FE, so you can go and get that information quite quickly. So you just flip over to the math section, and as you can see, vectors over here on the left, and then go to that page, identities right here. So there's a lot of identities, a lot more than what I'm going to try to get into right now, but yeah, just wanted to kind of show you the different stuff that's related to vectors. So A, B, C, and D here show different identities related to the dot product and the cross product. Cross product represented by the X, dot product by the dot. So what is that? If you're not familiar with any of that stuff, this is kind of what I've got here to try to break it down. So it's just kind of like a explanation, the notation, this section here. So A, B, and C are vectors. C is not going to be used in this. I just put it down because of the identity breakdown from the reference manual has C included. So I with an up caret on top of it. J and K are dimensions like X, Y, and Z. A subscript X, Y, Z, B, C are scale factors or scalar factors. They're used to denote like the length in the dimension or the value of the dimension. So if A were to be dot product with B, then the result of that would be AX times BX plus AY times BY plus AZ times BZ. So that's pretty simple, right? You're not going to get a another vector when you do a dot product. It's just going to be a value, a straight value. So with that being said, first one here is a dot product with itself equals 0. There's actually an identity that shows that vector dot product with itself equals the magnitude of that vector squared. So we know for a fact that that is incorrect. So disregarding all that, now that we know that, boom, problem solved, got A as the solution. But let's just take a look at the rest of these a little bit more. So one of the other identities here, C, A dot product with B equals B dot product with A, just switching the places. That's one of the identities found in the book, so that can't be it. So C is off the table. D, cross product. Cross product's a little bit more complicated. You have to find the determinant of a matrix in order to get the solution. So this is a matrix, if you're familiar with what those are. And these bars here represent performing the determinant on that matrix. Um, so matrix is basically just a set of values with rows and columns. Um, you can also have like vector notation, so it's not an actual value but more of a direction. So that's what's here. So yeah, this is kind of a breakdown. So it simplifies it a little bit more for how to get the different directional vectors and their corresponding scale values. Um, so this is a further breakdown for what to do to actually get the solution. Um, so with that being said, back to this answer D here. There's actually an identity that shows exactly that. So D is off the table. So C and D are off the table. I already know the answer is A, but let's just take a look at B. Um, there is no identity that. Wait, I'm sorry. So they actually don't have an identity for that in the reference manual that I can see. So the only way to determine between these two, then, even though that's already given as incorrect, you would take. Fastest way to do this is to just take your calculator and go to vectors, scroll over to math, cross product, select your vector, put a comma, select the same vector, close parentheses, and you get 0. So you can do that with two different vectors just to verify, but as you can see, that holds true. So A is the correct answer. It is not a correct identity. Hope that helped. Vectors are a little complicated, and I didn't go into all the details, but if you have any questions about anything, just let me know, and I'd be happy to expand on it. Thanks, everyone. Bye.